This video will focus on VLANs, or Virtual Local Area Networks, and how they allow you to segment a network without physically rewiring it. What exactly is a VLAN? It stands for Virtual Local Area Network, and understanding this concept is the core of this video. A VLAN is a logical grouping of devices on the same physical switch, acting as if they were on entirely separate networks. This means-on physical switch can support many logical networks. Consider this simple scenario. One switch connects 6 computers, and everyone is currently on the same network. The problem with this setup is broadcast traffic. When one PC sends a broadcast, it hits every device on the network. This wastes bandwidth and compromises privacy. When one computer acts as a sender and sends a broadcast, every other computer receives it, even if they don't need the information. This is a broadcast domain issue. Another problem is a lack of separation. When different departments like HR, sales, and engineering share the same broadcast domain, their data and traffic mix together. This is where VLANs offer a solution. They allow you to take one physical switch and logically split it into multiple virtual networks. With a VLAN setup, one physical switch can be divided into 3 separate, isolated virtual networks, such as VLAN 10, VLAN 20, and VLAN 30, all on the same physical hardware. Each VLAN can be assigned to a specific department and its resources. For example, VLAN 10 for sales, VLAN 20 for HR, and VLAN 30 for engineering. PCs connect to access ports, which are assigned to a single VLAN. The switch automatically assigns the VLAN to the traffic, and the PC doesn't need to know VLANs exist as the traffic flows untagged. A trunk port, on the other hand, carries traffic for all VLANs between switches. This link uses 802.1q tags, so the receiving switch knows which VLAN each frame belongs to. 802.1q is the standard enabling VLANs on trunk links. It works by inserting a 4-byte tag containing the VLAN ID into the frame before sending it on a trunk. The tag is added when a frame enters the trunk and removed when it exits. This process ensures the destination PC never sees the tag, maintaining a normal, untagged experience. When 2 switches share the same VLAN, such as VLAN 10 on switch A and switch B, the 2 computers on that VLAN share one logical network, even across different physical switches. By default, VLANs cannot talk to each other. A Layer 2 switch will block traffic between VLAN 10 and VLAN 20, for example, maintaining separation. To allow VLANs to communicate, you need inter-VLAN routing using a Layer 3 device, like a router or L3 switch. A common method is router on a stick. The native VLAN is the one VLAN that travels untagged on a trunk link. While the default is VLAN 1 on most switches, it's best practice to set it to an unused VLAN ID for security. You should not use VLAN 1 because every port defaults to it, including unused ones. This is a security risk as unplugged ports could auto-join the management network. Instead, use a dedicated, non-default VLAN for user traffic and shut down unused ports. A voice VLAN setup allows both a phone and a PC to share one cable. The phone tags its voice traffic with a priority VLAN, while the PC's untagged data traffic is placed in a separate VLAN by the switch. The management VLAN is an admin-only network to manage your switches. It's a best practice to dedicate a VLAN ID for this purpose so regular users cannot even see the management network. VLANs provide security through isolation. Separating departments like HR and sales, or guests from internal servers, ensures that a breach in one VLAN does not expose others. Another benefit is a smaller broadcast domain. Without VLANs, you have one huge broadcast domain. With VLANs, you have several small ones, meaning less wasted bandwidth and a faster network. VLANs offer great flexibility. If a user relocates, you only need to change a single port's VLAN assignment. This saves on physical rewiring, re-IP addresses, and makes network changes logical, not physical. Finally, VLANs improve performance. Broadcasts are confined, reducing CPU load on devices. This ensures critical traffic, like voice, receives the necessary bandwidth alongside data, improving throughput on the same hardware. To recap, VLANs are virtual and isolated. They use tagging on trunks and require routing for inter-VLAN communication, This leads to better security, less broadcast traffic, and more flexibility. Thank you for watching this video on VLANs. They provide illogical networks, better security, and a smarter network design.